ME416 Project 4 Finite Element Analysis of Heat Transfer in Fins by Trenton Hicks and Lindemulder. The purpose of this project was to use ANSYS Workbench to compute the rate of heat transfer in two different fin geometries and compare it to an analytical solution. The fins should have an infinite length and be made of aluminum and copper. We used a rectangular fin geometry and a triangular fin geometry. Using NX, we modeled our fins with a length of 10 centimeters so that it was long enough to be considered infinite, then imported them into ANSYS Workbench. We then computed a temperature mesh and a heat flux mesh for each fin and material. The aluminum rectangular fin had a temperature of 114.7 degrees Celsius at the end of the fin when the base was maintained at 150 degrees Celsius. The rectangular copper fin had a temperature of 126.27 degrees Celsius at the end of the fin. The temperature at the end of the aluminum triangular fin computed by ANSYS was found to be 120.69 degrees Celsius, and the temperature at the end of the copper triangular fin was computed to be 119.16 degrees Celsius. We then used ANSYS Workbench to create a heat flux mesh to compute the rate of heat transfer through the fin. We also used equations from a heat transfer textbook to calculate our analytical solution for the heat transfer rate. We compared the two for each fin and recorded our percent error. For the aluminum rectangular fin, we had a percent error of 2.62%, and for the copper rectangular fin, we had a percent error of 7.14%. Our percent error for our aluminum triangular fin was found to be 1.38%, and our percent error for our copper triangular fin was found to be 1.77%. Since all of these percent errors were relatively low, we concluded that the analytical equations we used can be used safely to calculate an accurate heat flux through a fin.